Hi everyone, and welcome to the Mat 211 review of mean, variance, and standard deviation. My name is Julia, and I work for the tutoring centers at ASU. So, workers' salaries are uniformly distributed in a company between $20,000 and $50,000 per year, dollars per year. What is the average salary? So the first thing we need to do is determine our probability density function. We know that, we'll call it f of x here, and we know that f of x has to be non-negative. This is because it's a probability density function, its values have to be between 0 and 1. Or 0 and 1, there we go. So we also know that f of x has to have negative infinity to positive infinity. If we integrate f of x with respect to that, so f of x dx here, it has to evaluate to 1. Now, so we're saying negative infinity and positive infinity here, but notice that our range is between, 20,000 and 50,000. So anything outside of that range will have a probability of 0 because in this company, people don't get salaries outside of that range. So we can replace this with those two endpoints. So our lower bound would be 20,000 here, and our upper bound would be 50,000. Also, f of x has to be constant because it's uniformly distributed. That means that the probability of getting 30,000 or 35,000 or anything in between this range, all of the probabilities for each of those different values that you could have in between 20,000 and 50,000 are exactly the same. So we know that f of x is going to be a constant value. This means that we need to figure out what that value is, and it's just going to be a numeric value. There's going to be no x's associated with it. So let's go ahead and sub in for f of x here. We'll say that f of x is equal to a, some value a, and we'll substitute an a here. So a integrated between 20,000 and 50,000. And we know that that has to equal 1. So let's start by integrating. So if we integrate a, by d or by x here, dx, we're going to have a times x evaluated between 20,000 and 50,000. Oops. Not 500, or there we go, 50,000. There we go. So we want to evaluate that. That means that we're going to have a times 50,000 minus a times 20,000, which equals 30,000 times a. Now we know that we need to have this equal to 1. So if we set this over here, we've got 1 equals 30,000 a. Therefore, 1 over 30,000 is equal to a. So our probability function f of x is equal to 1 over 30,000. Now that we know what our probability density function f of x is, we can determine the average. Now remember that the average, or the mean, is the same as the expected value of x. So if we have the expected value of x, which is equal to our mean, which is our average, this is equal to us integrating from negative infinity to positive infinity of x times the probability that big X is equal to little x here. So this is little x in this case. And since we're denoting both here, I'll write my little x's as a curly x. Times dx. Now this probability that big X takes on some value little x is simply our probability density function, f of x. So we can go ahead and substitute that in here. So we know that our f of x here is 1 over 30,000. Also, again, we have that negative infinity and positive infinity don't really matter here because we can't have any values outside of 20,000 up to 50,000. So we can substitute those values in. Now that we have this, we can go ahead and substitute in, or we can go ahead and integrate. So if we integrate this, we're going to have 1 over 30,000, because that's a constant, times x squared over 2. We'll evaluate that at between 20,000 and 50,000. This equals, if we just simplify it a little bit, this is x squared, or rewrite that, x squared over 60,000, evaluated between 20,000 and 50,000. So if we want to do the math on this, we have 50,000 squared, because we're just substituting 50,000 in for x here, divided by 60,000 here, minus 20,000 squared over 60,000. Now these are big numbers, so I'm not going to write them in, but I will tell you what this evaluates to is 35,000. So our average salary, which is our expected salary here, is 35,000. And that's it. We're all done. Before I go, I just want to remind you all that if you're looking for any additional tutoring or academic support at ASU, you can go to the Tutoring Center's website, tutoring.asu.edu, to find all of our resources. Also, if you're looking for tutoring for your specific course, you can use our Tutor search tool, which you can find at our main website here, or by going directly to the Tutor search tool at this full link on the screen. So thanks so much and have a great rest of your day.